Injury to this area leaves us unable to process new declarative memories. One famous patient, known for years only as HM, had both his left and right temporal lobes, hippocampi, removed in an attempt to help control the seizures he had been suffering from for years. Corcoran, Amaral, Gonzalez, Johnson, and Hyman, 1997. As a result, his declarative memory was significantly affected, and he could not form new semantic knowledge. He lost the ability to form new memories, yet he could still remember information and events that had occurred prior to the surgery. The cerebellum and prefrontal cortex, although the hippocampus seems to be more of a processing area for explicit memories, you could still lose it and be able to create implicit memories, procedural memory, motor learning, and classical conditioning, thanks to your cerebellum. Figure 8.8. For example, one classical conditioning experiment is to accustom subjects to blink when they are given a puff of air to the eyes. When researchers damaged the cerebellums of rabbits, they discovered that the rabbits were not able to learn the conditioned eye blink response. Steinmetz, 1999. Green and Woodruff Pack, 2000. Other researchers have used brain scans, including positron emission tomography, PET scans, to learn how people process and retain information. From these studies, it seems the prefrontal cortex is involved. In one study, participants had to complete 2 different tasks, either looking for the letter A in words, considered a perceptual task, or categorizing a noun as either living or non-living, considered a semantic task. Kapoor et al. 1994. Participants were then asked which words they had previously seen. Recall was much better for the semantic task than for the perceptual task. According to PET scans, there was much more activation in the left inferior prefrontal cortex in the semantic task. In another study, encoding was associated with left frontal activity, while retrieval of information was associated with the right frontal region. Craig et al. 1999. Neurotransmitters. There also appear to be specific neurotransmitters involved with the process of memory, such as epinephrine, dopamine, serotonin, glutamate, and acetylcholine. Mirror, 2003. There continues to be discussion and debate among researchers as to which neurotransmitter plays which specific role. Blockland, 1996. Although we don't yet know which role each neurotransmitter plays in memory, we do know that communication among neurons via neurotransmitters is critical for developing new memories. Repeated activity by neurons leads to increased neurotransmitters in the synapses and more efficient and more synaptic connections. This is how memory consolidation occurs. It is also believed that strong emotions trigger the formation of strong memories, and weaker emotional experiences form weaker memories. This is called arousal theory, Christianson, 1992. For example, strong emotional experiences can trigger the release of neurotransmitters as well as hormones, which strengthen memory. Therefore, our memory for an emotional event is usually better than our memory for a non-emotional event. When humans and animals are stressed, the brain secretes more of the neurotransmitter glutamate, which helps them remember the stressful event. McGaw, 2003. This is clearly evidenced by what is known as the flashbulb memory phenomenon. A flashbulb memory is an exceptionally clear recollection of an important event. Figure 8.9. Many people who have lived through historic and momentous events can recall exactly where they were and how they heard about them. For example, a Pew Research Center 2011 survey found that for those Americans who were age 8 or older at the time of 9/11 terrorist attacks, 97% can recall the moment they learned of this event, even a decade after it happened. Many widely discussed examples of flashbulb memories pertain to national or global events, but according to their initial definition by researchers Brown and Kulik, 1977, as well as additional work by more recent researchers, such a widely shared event is not required. Hurst and Phelps, 2016. Family members might always remember how they heard about an important event in their lives, or people in our school may recall nearly everything about the way they experienced a major event in that setting. And although most studies and many conversations involve negative memories, positive events can also elicit flashbulb memories. A photograph shows the World Trade Center buildings shortly after 2 planes were flown into them on the morning of September 11th, 2001. In thick black clouds of smoke streamed from both buildings. Figure 8-9. Well, most people can remember where they were when they first heard about the 9/11 terrorist attacks. This is an example of a flashbulb memory, a record of an atypical and unusual event that has very strong emotional associations. Credit Michael Foran. Dig deeper, inaccurate, and false memories, even full